Let's balance some equations. In so doing, we have to keep in mind the law of conservation of matter. That matter is neither created nor destroyed in a chemical reaction. We harken back to John Dalton and his atomic theory that said that atoms do not change form during a chemical reaction. And so the bottom line of that is, as we go from reactants to products, that the number of atoms of each type has to be the same on either side of the reaction arrow. So the first reaction, H2 gas plus O2 gas, reacts to make H2O, this liquid. Molecular hydrogen plus molecular oxygen reacts to make water. Now remember that hydrogen and nitrogen and oxygen and the halogens all exist as diatomic molecular species in their pure form at room temperature and pressure. So let's see what we've got. We've got 2 hydrogens on the left, 2 on the right. So far, so good. 2 oxygens on the left, only 1 oxygen on the right, on the product side. We don't have enough oxygens. We cannot go changing subscripts. We can't just all of a sudden put a 2 after that oxygen, because now we will have changed that water into hydrogen peroxide. And that's a no-no, and you wouldn't want to drink that hydrogen peroxide because that wouldn't be very good for you, needless to say. So we need more oxygens on the product side. So let's just boost that up by putting a 2 there. So that gives me 2 oxygens on the product side, 2 oxygens on the reactant side. Look at the hydrogens. Now they're no longer balanced. 2 hydrogens on the left, 4 hydrogens on the right. So I need more hydrogens on the reactant side, so let's put a 2 there. And now everything should balance. If you look at the reactant side, I've got 2 hydrogens plus 2 oxygens. 2 times 2 is 4 hydrogens. Don't forget that subscript there. 2 times 2 is 4 hydrogens on the product side plus 2 oxygens, and we're balanced. This is an example of a reaction where we're taking 2 molecules, combining them to make a third new molecule, so that we could call this a combination reaction. Whereas in number 2, we're taking a single molecule, H2O2, which is hydrogen peroxide, and breaking it apart into 2 different molecules. So this is a decomposition reaction. So let's do our balancing act. 2 hydrogens on the left, 2 on the right. So far, so good. 2 oxygens on the reactant side. I've got 1 plus 2 is 3 oxygens on the product side. So we need more oxygens on the product side. So let's try boosting that up by putting 2 in front of the water. Remember, balancing equations is a trial and error process. And as you do more of them, you'll become more facile at doing these. So let's see what we've got. H2O2 reacts to make 2 waters plus O2. 2 waters means 2 times 2. I've got 4 hydrogens on the product side now. So I need more hydrogens on the reactant side. So let's try 2 in front of the hydrogen peroxide. Now let's do our balancing act. I've got 2 H2, so 4 hydrogens, plus 2 times 2 is 4 oxygens, plus, so that reacts to make, on the product side, 2 times 2 is 4 hydrogens, plus 2 times 1 is 2 oxygens, plus 2 more gives me 4 oxygens. So we're balanced. The same number of each type of atom in either side of the reaction arrow. The next one is a reaction where we're taking sodium hydroxide, this is solid, plus H3PO4 aqueous, phosphoric acid, reacting to make sodium phosphate, this aqueous, plus water. liquid water. And so this is a type of reaction that we could call an acid-base reaction, and that we got phosphoric acid, and sodium hydroxide is a type of compound that we know as a base. We could also call it a neutralization reaction. Let's try to balance it, comparing the reactant side to the product side. 3 sodiums on the reactant side. 1 sodium on the reactant side, 3 on the product side. I need more sodiums. Let's try a 3 there. Now we got, in terms of oxygens on the left-hand or reactant side, I've got 3 oxygens in the sodium, 4 in the phosphoric acid. That gives me 7. Look at the product side. I got 4 oxygens from the sodium phosphate plus 1 from the water. That means I've only got 5 oxygens on the product side. So I need more oxygens. So I got 7 on the left, 5 on the right. I put a 3 in front of the water. Now I'll have 7 oxygens on both sides. And I've got single phosphorus, so it's balanced. So let's see what we've got. 3 sodiums plus a phosphate, plus 3 oxygens from the sodium hydroxide, plus 4 from the phosphoric acid gives me 7 oxygens. And then in terms of the number of hydrogens, I've got 3 from the sodium hydroxide, 3 from the phosphoric acid, so I've got 6 hydrogens. Let's see what we have on the product side. We've got 3 sodiums, that's good. A phosphorus, that's good. And now I got 4 oxygens from the phosphoric acid, 3 from the water. That gives me 7 oxygens. That's good. And then in the water, I got 3 times 2 or 6 hydrogens. And so 3 sodiums, a phosphorus, 7 oxygens, and 6 hydrogens. Voila. That guy's balanced. The next one, we're going to take ethene, it's a molecule that actually has a carbon-carbon double bond in it, and react it with oxygen to make carbon dioxide and water. We're taking a hydrocarbon, C2H4, and combusting it, burning it with oxygen. So we're doing a combustion reaction. And you need to know from here on out that the products of combustion reaction, whenever we got some sort of hydrocarbon or something that contains carbon, hydrogen, oxygen, we burn it with oxygen, the products are always going to be carbon dioxide and water. Okay. Let's balance. 2 carbons on the left, need 2 on the right. 4 hydrogens on the left, I need 4 on the right, so I'll put a 2 there. I've got 2 oxygens on the left, but now I've got 2 times 2 is 4, plus 2 is 6. So I need 6 oxygens on the reactant side. So what I can do is multiply the molecular oxygen by 3. And that will give us a balanced chemical equation. Got 2 carbons, plus 4 hydrogens, plus 6 oxygens. Reacts to make 2 carbons, plus 4 hydrogens, plus 2 times 2 oxygens from the carbon dioxide, plus 2 from the water, gives me 6 oxygens. Negative. Number 5, C2H6. This is a compound that's called ethane, plus oxygen, reacts to make carbon dioxide and water. Hopefully you recognize that this too is a combustion reaction. Let's see what we need to do to balance. 2 carbons in ethane, put a 2 in for the carbon dioxide. That way those atoms are balanced. I have 6 hydrogens from ethane on the reactant side on the left. Water has 2. So to get to 6, we'll put a 3 in front of that. Now the hydrogens are balanced. Now we need to balance the oxygens. I've got 2 oxygens on the reactant side on the left. From carbon dioxide, 2 times 2 is 4, plus 3 from the oxygens. I got 7 oxygens on the product side at the moment. Okay. One way to balance this is simply put a 7 halves in front of the O2. 7 halves times O2 equals 7. And that equals out the 7 oxygens on the right. So when you're thinking about moles, as opposed to individual molecules, that works fine. If you don't like the halves, what we can do is multiply everything by 2 to get rid of that half. So 2 C2H6 plus 7 O2 reacts to make 4 CO2 plus 6 H2O. And that guy should be balanced. 2 times 2 are 4 carbons, plus 2 times 6 are 12 hydrogens, plus 7 times 2 are 14 oxygens on the left. Gives me 4 carbons on the left. 4 times 2 are 8 oxygens in the carbon dioxide, plus 6 from the water. Gives me 14 oxygens, so that guy's balanced. And then hydrogen, 6 times 2 are 12 hydrogens, so the hydrogens are balanced. We've got a balanced chemical reaction. A little bit different, we had an extra step in there. The next two, we're going to try to use some of our chemical intuition to come up with chemical equations describing these reactions. This is going to be a combination reaction. We're going to yttrium. Yttrium is in group 3. Remember that. And fluorine. Remember, fluorine is a halogen, so it's going to be a diatomic molecular species. Room temperature and pressure, fluorine is a gas, and yttrium is a solid. We're going to react them to make some sort of yttrium fluoride compound. Well, which one are we going to make? Yttrium's in column 3, so it gets a +3 charge. Fluorine, when it makes an ion, wants to be a -1 charge. And so yttrium's +3 and fluorine's -1. To come up with a balanced formula for yttrium fluoride, it's going to be YF3. Now we're going to balance the equation. 1 yttrium on the reactant side, 1 on the products. That's good. Got 2 fluorines on the left, 3 fluorides on the right. So to get that to balance, let's multiply the side that's 2 by 3 and the side that's 3 by 2. And so now we've got 6 fluorines on both sides. 6F2 and 2 times 3 is 6F2. But now I got 2 yttrium, so to balance things out, I'm going to stick a 2 in front of the yttrium. And so now I've got 2 yttrium plus 6 fluorine, make 2 yttrium plus 6 fluoride, and that guy's balanced. The next equation, sodium is an alkali metal plus oxygen. We got to remember this, a diatomic molecular species, O2. It's going to react to make sodium oxide. Turns out both of these, the product before and this one too, will also be a solid. So let's balance. 1 sodium on the left, 1 on the right. That's good. 2 on the left, only 1 on the right. I can't just slap a 2 down after that oxygen. I can't play around with the coefficients. But before I do that, I need to make sure I've got the right formula for sodium hydroxide. So is NaO the right formula? What charge does sodium get in a compound? Ionic compound? It's in group 1, +1. and each oxygen is -2. So here I've got to make sure before I go balancing my atoms overall that I've got the right formula for the compound, and that's going to be Na2O. So now let's balance the atoms. 2 sodium on the left. Let's try 2 in front of the sodium. 2 oxygens on the right. I've only got 1 on the right on the product side, so I need to put a 2 there. But now I have 4 sodiums on the left. Like I said, this is a trial and error process. We're going to come back and make that a 4 in front of the sodium. 4 sodium plus 2 oxygen react to make 4 sodium plus 2 oxygen. We're balanced. We could call this a combination reaction. And although we didn't say so with the first one, the number 6, this is also going to be an oxidation reduction reaction. But more on that on a later date.